So a student gave me a question regarding the technical interview lectures, and I figured I'd go ahead and record a quick video to demonstrate a solution. So the question was, is there a better way to generate binary than with this sort of for loop construct? So for I in range 2, and I'll just take this, and let's make 4-bit binary, I, J, K, L, and we'll just, we'll pack this into a list. So binary list, bin list gets that, and bin list dot append, and we'll append a list, so it'll be nested, and this is just going to be I, J, K, L. So this is going to produce 4-bit binary. I'll just make this its own function, right? So def 4-bit binary lists, sure, and no parameter in there, and then we can just return bin list. Yep, and let's call that. So let's print the print 4-bit bin lists, and just see what happens when we run that. So this is going to be here. Tell me.py. Okay, and that looks good. Maybe I'll make this a little nicer. We'll just do for list in that 4-bit bin list, and we'll print list. So just take another run of this, and you can see that we've got a list of all these values. And if we wanted to enumerate it, that would be easy, right? We could do for IDX or for dec, do dec. So we'll talk about that. Enumerate 4-bit bin lists, and instead of printing just the list, we could print the dec. And you know what? I'll do this. Do this and that. So I'm just going to make this an F string, and okay, that seems right. Yep. So we've got the decimal on the left, we've got the binary on the right. So we can do that. And to add another bit, like what if we wanted to do 6 bits? Well, we'd have to make 2 more for loops in here, 2 more letters. What if we want to do this for an arbitrary length? So let's explore that. I'm going to just push this down really quick. Clear my terminal, and comment this out, and we'll just drop it down and leave it down there at the bottom. Okay, so let's break this into a couple problems, right? So we want to, essentially what we want to do here is we want to generate a list of binary. Let's say this is from, we could do a low to high decimal, like say from 0 to 256 or something like that. But let's do all counts for some n length or n bit binary list. And for some n bit binary range, let's say from that'll be from 0 to that'll be n to the 2 to the n bits. Okay, so that's our problem. Now, the first thing we might want to tackle here is actually just doing a simple decimal to binary conversion. That's probably where we want to start. So let's start there. Let's make a function called dec to bin, so decimal to bin, and it's going to take some decimal number. It's also going to take the n bits, right? So this is going to, let's just default this to 8. You know, that's a pretty common thing to do. 8, 16, 32, 64, right? And, you know, we're going to want to call this, we'll print dec to bin, oops, dec to bin on, let's do 34. So we're going to convert 34 to decimal, and we'll just leave n bits at 8 for the time being. All right. So, you know, let's just return none to start and make sure that there aren't any glaring errors here or anything like that. So Python delme pi. Oop, there is some kind of error. End of file while parsing. Where am I seeing this? Line 43. Oh, okay. All right, so let's go ahead and run that again. Oh, still same error. You know what? Ah, missing paren right here. Common error. On line 8, I was missing the a second closing paren. So, all right. So we're returning none. This little function stub is doing something. Cool. So we're going to want this binary list returned in, well, it's going to be a list, right? So let's start with a list accumulator. You know, this is going to be an accumulator pattern. So the algorithm for this, I'm going to code it out and talk through it while I'm coding it. It's pretty straightforward. It's kind of a neat little thing. We're going to take this initial decimal number, and we're going to just save it into a value x. So whatever dec is, right? In this case, it's 34. It's going to go into x. That's pretty straightforward. And yeah, so that's where we're starting. All right. And you know, so these are our initial kind of values. Now, what I want to do is take x and apply the modulus to it. So I'm going to do modulus 2, and whatever the remainder is, that's going to be the furthest right bit value. And so I can just continually append to bin list. However, you know, keep in mind that if I do that, well, I'll demonstrate this. If I do bin list dot append, you know, x modulo 2, and I do this over and over again, I'm going to be packing in a list from the right, right? So it'll be something like this. It'll be traveling in reverse from the way that we want the binary to travel. We want to go left to right. So what I'm going to do, I'm going to ultimately go right to left, you know, at the end. But I'm going to go ahead and just, for the moment, treat this list like kind of a, you know, I'm going to pack it in from left to right, and then at the end, I'm going to return the reversed list. That's kind of a nice little way to take care of this. So for I in range n, and notice this is actually n bits, so I'm going to traverse, I'm going to run this loop, sorry, n bits times, right? Because that's how long our list is going to be. This is how many things we're going to append to the list. I'm going to say, well, here's the bit, and it's going to be x, this value on line 5, that's on the first iteration, is the original decimal input, and I'm going to get the modulus of that. And you know, if this is an even number, then this is going to be 0, and our rightmost value in binary for any even number is 0, and the rightmost value for any odd number is 1. So this is our bit. And I'm going to say, well, let's just take bin list and append that. Okay. So that's going to give us something, but we need to modify x. Okay. So why don't we go ahead and do that? And keep in mind when you're thinking about this, binary sort of has this. Let's say we've got this binary value, and this is of course 0. This is the ones place, right? And this is the twos place. This is the fours place. This is the eights place. Nope, not there, there. And on, right? 16, 32, 64. So we want to actually get the, we want to get x divided by 2. And notice I'm doing a floor division here. I could also just do this. Okay, x floor divided by 2. And when all of that is done, we'll find out if I'm lying or not. When all of this is done, we should get the binary value of 34. So, just to sort of prove what I'm talking about, let's start with 0, and this should give us 8 zeros. So it does. Let's go 1. This should give us 7 zeros and a 1. Oh. 1, 2, 3, 4, 5, 6, 7, 8. Interesting. What is happening here? Oh, I didn't save it. Here we go. There we go. All right. Very common error that I make. I don't save and run my code. I'm like, nothing's different. Okay, so 7 zeros and a 1. Let's look at the value for 3. This should be a bunch of zeros, 1, 1. And it is. And let's look at 256. What's happening there? Oh, wait a minute. Yeah. Okay, that was a little silly. I was like 256, and really I should have said 255. 255 is all ones, you know. So, and if you think about that, that makes sense. This is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. All of that adds up to 255. So 0 to 255. And what's cool about this is if I put in 256, it actually rolls over. It's pretty wild, right? It's a little surprising that it does that. Yeah, so this is a fairly simple algorithm, right? You get the remainder, and store it, and in this case I'm appending it, and then you get the let's say the current value divided by 2. You can just do that over and over again until until you reach the end. And you could set this up as a while loop if you didn't want to prepend zeros in your list. So then you would be sort of compacting the binary and only representing everything up until you're packing in zeros to the left. Cool. So we've got that. And you can imagine if we want to pack this into a bunch of lists, we've got a really simple step here, and I'll just sort of illustrate that. So for I in range, well, what should we do? We should do 2 to the n bits, and let's just set n bits to 8, even though, you know, we're already doing that, and I'll just change that to n bits. And we can do I, so this is going to go between 0 and 255. So let's just prove that to ourselves. Okay, missing a colon. All right. So that's doing what we'd want it to do. You can't see all the way at the bottom, but it goes to all ones. So that's kind of nice. Why don't we just pack this into another function? So I'll just call it get binary, and we'll default this value of n bits. So that'll be our parameter. And instead of printing this, let's pack something in. So let's do bins list, and we'll just do bins list dot append that, right? So these function calls, and now we can go ahead and just return the bins list. And let's run this for a list in, scroll down just in case it's getting a little hidden, for a list in get binary, and let's do n bits of 5. So this should be just a 5 length list as opposed to an 8. And we'll print, let's just print each of these lists that are in there. Let's see how that goes. And that worked. Cool. What if you wanted to have a dictionary instead of this bins list? Well, why don't we do that? And this time we'll do for I in range 2 to the n bits, and instead of, so we'll just call this bins d, I guess, and we'll do bins d sub I, and that's just going to get this dec to bin of I and n bits. So the result of this function call will be packed into and associated with that that key, which is the decimal value, as it turns out. So now let's say for LST, nope, let's do for dec, comma bin with an underscore in get binary of n bits of 5 dot items, because it's a dictionary. Now let's print the let's do an f string. We'll just do dec and bin, and barring any errors, I think that will work. So let's find out. Yeah, that worked. So I'm going to link to a REPL that contains this code in, I'll probably just leave it in the dictionary form. Maybe I'll throw the list form in there too, either way. You know, so you can play around with it. But pretty straightforward, not particularly difficult, kind of fun. Gets you out of this heavily nested for loop paradigm. You know, the only thing I'll change here, we're not using this I, and it's just nice to use an underscore there because we know that we're not using it if we do it that way. And yeah, that's it. Have fun with it, and see y'all soon.